Shall we reveal our mystery speaker from Mania?
Oh, that's a good one.
Okay, Google. Who is Frontmania 2018 mystery speaker?
Lee Boonstra is the mystery speaker of Frontmania 2018.
Okay.
Give a round of applause, guys.
Okay. Okay, Google. Can you tell a little bit more about her?
Lee Boonstra is a customer engineer at Google, at the Google Cloud team in Amsterdam, where she assists the sales team with technical knowledge for the financial industry.
I understood Lee, Google. She will tell you more about herself. Let's welcome, with a big round of applause, Lee Boonstra from Google.
So hi everybody, my name is Lee Boonstra, and I work as a customer engineer for Google, and that means that I visit lots of customers, and in my case these are the banks and insurances companies in the Netherlands, and then I talk about Google Cloud and a lot about machine learning. I see some familiar faces here, so some people might have seen me before. Before I start, I was wondering, are there any data scientists here in the room? No data scientists? One. That's good. Because I'm going to show you how you as developers can also play around with machine learning today. So what is machine learning? Think about it as how you learned something as a kid. How did you learn your Dutch language or English language? I bet your parents didn't came over and they handed you a dictionary and they told you now you have to read it from A to Z. And by the last page of the dictionary, then you mastered the Dutch language. No, we as kids learned from examples. So, for example, we saw a car driving on the street, and your parents said, like, look, that's a car. It has 4 wheels and it drives on the street. Okay, look, and that is a bike. It has 2 wheels and it rides on the road. Okay, and as soon as you would see enough bikes and enough cars, then you would distinguish both, and you would know which one is a car and a bike. And then, as a kid, if you would point to a truck, for example, and say, like, hey, look, that's also a car. And your parents would probably say, like, no, that's not a car, that's a truck, because it's bigger, and you would correct it, right? And then at some point, you start learning much and much more things. It's the same for how it works for machines. So in machines, machine learning, it's all about like data scientists. They create a model, and then they feed it with lots and lots of data. And at some point, the machine will start to recognize patterns. So it will understand and can classify objects, for example. And then if the machine would have it wrong, set it the wrong way, then we would correct the model and say, like, well, next time when you see this data, then you should give this as a result. So why is machine learning so popular now? Well, the reason is, like, first of all, we have much and much more data over time. I believe that was in the past, especially as front-end developers, we always got told, like, oh, when we build apps, we build mobile first, because if you build mobile first applications, then you can start creating and incorporate much more screens and so on. We would create lots of apps, and all those apps would collect lots of data. We at Google do that, obviously, but I think you all, as engineers working for companies, you collected lots of data through your apps as well. And now it's the time that we finally can make smarter applications. Because we have so much data, we can learn from the data that we collected and start to run patterns around it. So that is one thing. Obviously, we have more data, better models, but the other thing is the computing power. Like, think about all these data centers, like these rooms where like, racks of computers are available, and you can use these machines, the power, but also the storage to start training these models. So let's do some machine learning here. Let's classify which one is a dog and which one is a mob. And I bet you guys think, like, well, that's easy. I don't need machine learning for that. But maybe Maybe we're not that sure about this. So typically, if we would use machine learning for this, then what we would send these pictures to a data model, and then this model, this machine learning model, will give us results back with confidence levels. So in this example, you can see, like, yeah, this is clearly a dog. I am 99% sure. But I am not so sure if it's a dog crossbreed. See, that's like 51%. So that means that we need to train it with more data. I need to send more data to this machine learning model, and then eventually the model will become better, and it becomes smarter over time. It kind of works like how it works in your brains, like the neural networks. Like what we do is like we look at the picture on pixel level, and we start looking, and in this example, it's like, is it a cat or a dog? Like, based on this amount of pixels, is it a cat? Okay, now we look at more pixels. Is it now a cat or a dog? Is it a cat or a dog till it visit the whole image? And then we can finally say with some sureness, like the confidence level, like, yeah, I'm really sure this is a dog. And machine learning, that is part of artificial intelligence, AI. AI, that is the process of building smarter computers. And machine learning, that is the process of making computers learn. And then an observation is made, it is actually easier to make computers learn than to build smarter computers. And if you think about it, like as all engineers, as engineers, like you would write if-else code, start branching. At some point, your code would break. There's always a reason how your code will break, and then there's always a boss that comes in and says, like, okay, now your code needs to do this. Oh, so we need to start working on our code. With machine learning, that's different. We just feed more data, and eventually it will become smarter, right? So why do people think about Google when we talk about machine learning? Well, that is because lots of data scientists, they use TensorFlow. TensorFlow, that is a machine learning framework. It started as a Python framework. Nowadays, it can also do JavaScript. You can train with JavaScript, which is nice for if you want to train, for example, with mobile devices, phones, because you can make use of the sensors. But TensorFlow is an open source framework, and it's very popular in the machine learning community. And you would use this to create a model, to train it, and then, yeah, you can start using it. Now, Google is an AI company, and you know that. It started already with Gmail. I think the spam filter, that was one of the first machine learning models to classify if incoming mail is spam or not. And if Gmail would say it wrong, then you would say, like, actually, this is not spam, and the model would learn based on your actions. The recommendations in YouTube, that's machine learning. But also the Google Home, that's machine learning. It knows, it can listen to your voice, understands what you're saying, and then switch for an answer. The Waymo, the self-driving car, is all about machine learning. It's a car with cameras and sensors around it, and then it makes decisions while it's driving around. It knows, like, oh, there's a bike riding next to me. Oh, if it's on the same way, well, what are the chances that the bike will hit me? That's different than if you're on a crossroad and you see a kid on the other hand, right? Then suddenly machine learning needs to think much more. This is also an example of machine learning. I think this is nowadays native in the Android camera, the Google Lens. But we also have like machine learning models for this that you can use. You can point your camera on some different language, and on the screen it will show you exactly what it means. So first of all, it does OCR detection. It starts to read the other language, and then it does the translation, which is also machine learning, to translate the text. Yeah, Google Home, like I mentioned before, like it's all about machine learning. We'll talk about it today. I'm going to show you some examples about that as well. Yeah, so you will probably also make use of machine learning. Like in the banks, we would use machine learning for fraud detection, for example. And like if you work for a retailer, you probably want to use machine learning to do recommendations. There are all kinds of machine learning things that you can start using it for. But here's the thing. There is a lack of machine learning expertise in our industry. Like, machine learning is hard. It's difficult. Like if you see here on this screen, you see like there are like 21 million developers. And from those 21 million developers, only 1 million or less than 1 million is a data scientist. And even less, like thousands of those are like deep learning experts or researchers. So that shows you it's difficult. You know, I'm a developer myself. I'm not a data scientist. I don't know anything. I was very bad in mathematics when I was young. Data doesn't really, I mean, like, I can read data, but I mean, I'm not a data scientist, so I cannot build a model myself. So this is why I am happy as a developer to figure out that there are tools that can do this machine learning process for you. Like, think about like pre-processing the data, designing the model, tuning the parameters, evaluating your models, and then deploy it. And not only like this process that makes it easier, it's also that because we do that in the cloud, we can also do it very fast. So instead of training a model and wait for weeks, we can just train it in a couple of hours. Because like a data center has all these machine learning the compute. We can just connect like multiple machines, start them running, and then the answer, the trained model, comes back to me. Oh, whoa. Yeah. So how can you use machine learning? Well, there are actually a couple of ways as developers. Like first of all, yeah, if you are a data scientist, or if you're really good in TensorFlow, yeah, you can start using that. Comes in Python, comes in JavaScript. I'm going to talk to you today about the pre-trained models. And this is really nice because that means us developers, we can just make use of APIs. We can call a REST service, we point our application to a URL, and then we submit data to those URLs, and then the model, the pre-trained model from Google, will return you the results. And you don't need to train models yourself. You don't need to build models. This is really easy. The other solution that we can do as developers is we can start building conversational solutions. So think about Google Assistant apps or chatbots. This is also all about machine learning. And this is also very easy for a developer because we have SaaS solutions for you where you just log in into a portal and start tweaking models. No mathematics needed. Like even business people could train models this way. And then the last thing that I like to point out, that is AutoML. So you have TensorFlow. This is for the data scientist. This is really great, like TensorFlow, if you want to build a custom model. So let's imagine that if you're building a machine learning model for a bank, yeah, you obviously don't want to expose this model to the real world. You want to keep your model for yourself, and you want to train it based on your own banking data. So that's unique. Only you as a bank has that data. So typically people will use TensorFlow for that. A pre-trained model, that's the other end. That's like one of the machine learning models from Google that you can start using. But that's not exactly what you need, because if you want to make something custom. So with AutoML, you can use the best of both worlds. And I'm going to show you that today. I'm going to give you a demo how you can start doing this yourself and build your own machine learning models. First, I'd just like to highlight the out-of-the-box pre-trained models that are available, which you can also already start using. We have models to understand images. We have models to understand video, speech. This is the Vision API. This is just to understand an image. So if you, as a developer, talk to a URL and you submit an image to it, then it will see what's in the picture, and it returns a JSON file, tells you, this is what I see on the picture. I can see sentiment from faces. People are smiling. It won't tell you who the person is, but it tells you the sentiment, or if he wears a glass or a hat. It has OCR detection, so that means you can use it to read text from an image. So imagine, again, I'm mostly working for the banks, but imagine that you have a PDF with all handwritten or text from a user, and you can just pass it to the model, and the model spits out text. And that you can store that in your databases. And the last thing that the Vision API does is it can detect inappropriate content. So if, let's say, you're building a content management system or something, and people can upload images, what you don't want is that people upload violence, right, or pornography, because then suddenly it's on your databases. You don't want that. So that is something that the machine learning model could flag as well, and it could tell you, hey, let's not store this one. The Video Intelligence API is kind of similar like the Image API, but instead of watching, my first initial idea was, it's probably just takes from a video every shot as an image. What's so special about it? Yeah, it does that. So everything that the Vision API does, the video API can do as well, but it can also understand the overall context of the video. So that is really nice, especially if you work in media, in the media sector. If you work for a TV channel and you upload like lots and lots of video files, you can start tagging your videos, or you can see if you have a sports message, like on which minute a goal was made. The speech API I'm using a lot at the banks lately. That is what you could do first. You can do two things. One is you can speak into the model through a microphone, or you can upload an audio file, and then it gives you the transcribed version, so the text version of what you said out. It spits that out, and it can also do the other way around. So if I send in a text, it can read it out for me in a very human voice. And maybe you've seen these demos, or like the WaveNet demos online, where we can create machine learning voices that sound like a real human voice, even with the uhs and ums, and that's just to make it so natural. Yeah, so Speech API, we can just take your audio and we can text, or the other way around, and we do that in all kinds of languages. Natural Language API, this is one of my favorite. It can understand what has been said, or it can understand the text. This is what the Google Home does. When you talk to the Google Home, it starts understanding what has been said. But with the model, it can detect the entities. It can see like, oh, this is a company, this is a person, this is something syntax. And you can also use it to detect sentiment. So you can say like, well, this person was really angry, or this person was very happy. And if you're like doing this on top of social media, this is super interesting, right? To get all these details. So, a pre-trained model versus learning TensorFlow. Maybe you're now thinking like, yeah, well, both is not really what I'm looking for. Like, I don't want to code TensorFlow and understand the data and build the model myself. But the pre-trained models, those are not good enough for me because I want to make something very unique and very special. So this is where the AutoML comes in. That's the best of both worlds. Developers, they understand the machine learning APIs, and data scientists, they understand TensorFlow. If you see it, look at this example. Typically, in a machine learning API, if you would upload a photo, it would tell you this is a cat. But maybe you want to create a custom model that instead says this is a cat. This is the cat named Bob. Yeah, Google doesn't know that this cat is Bob. That's something that you need to train. Yeah. So we're going to do that. And how that works is you upload the data set. And this is an example of AutoML Vision for then if you upload video or photos, then it starts, then you can start labeling it, and then it spits out a model for you. It takes a Google model, the pre-trained Vision API model from Google, and on top of that, it puts your own data, and then you train it with your own data, and then you can create this example of this cat is Bob instead of this is a cat. So it goes through an interface where it's a web interface where you just upload CSV file and then you start training it and evaluating it. And I think this is a great moment to show you this in action, how this works. So this is a demo application that I created. I just created like a fake banking page. And yeah, what I like about this fake banking page is like, normally, when you show transactions, I think it's much more natural to ask, did my salary came in, instead of entering the account of your company and to check the salaries. So I created an example like that. I could say, like, how much have I spent on taxis? And if I hit enter, then suddenly it starts filtering this grid. Now, this is an Angular 7 application that I created with a data store behind it. And the only thing that it does is as soon as it knows that it's a taxi, then it starts filtering on taxis. It uses the natural language API here because, like I said, like how much have I spent on taxis, or did my salary came in? And then it understands, actually, we're looking here for negative transactions with the category taxis or category salaries. This example only would work if you have transaction data that has been labeled. So if you have, like, if you tell everybody, like Uber, that is a taxi, and McDonald's is a restaurant. I don't know this out of my head, and the pre-trained Google models don't know this either. So I was thinking, let's use AutoML to train our own model that can, based on a text, classify it and put the right tag on it. So to detect if it's taxis or restaurants or shoppings. And actually, that is really easy. So what I did is I opened a Google Sheet where I just start labeling data. So in this case, and I hope you can read it, I just fill in some sentences. And like, for example, how much did I pay for water? And I classify it as a utility. I make that label myself. And I did this for all kinds of labels, for shopping, for restaurants, for flights. Actually, honestly, to be honest, this took me the most time to do because I'm not a data owner. If you are a bank, you obviously have a lot of transaction data. You don't need to do it. Yeah, you need to label it, but you don't need to come up with all these sentences. Now then, the next thing that you can do is once it's a sheet, you can export it to a CSV file. And I save that CSV file on my machine. And then I go to the AutoML interface of Google. Now, I just create a data set here, so I can give it a name like taxonomy. That's what I did. And then I upload the CSV file that I just created. And then I click Create Dataset, and it will start training the model. And now here comes the thing. Normally, if you train a model, especially like a natural language model, this is like a very complex model. This would take weeks in general. But because this is all in data centers, yeah, we can do this very fast. We can do it in a couple of hours. So we take Google's model, natural language, put our own classifying logic on top of that. We train it. And then after a couple of hours, this will be done. And you get the results back. So if you go to the Evaluate page, you see here we did some. Yeah, we looked at the data, but it's really nice, so I don't need to separate my data myself. It just takes from my data set, it uses a part of it as evaluation data, so that those evaluation data hasn't been trained. That's just been for testing. So from my example, you see here, like, I use 200 training phrases. That's actually a little less. Typically what I would do is I would per label use like 100 training phrases. So I actually should have had much more. But then Google understands, like, oh, we just take like half of it as training data, and the other 25 is for evaluating and testing. So based on only these 200 sentences, you can see that my precision is actually really good. It's just 200 sentences, and I get a precision score of 87% almost. So that's really good. So that means that in general, I can trust this model, and it will return a right result. It also means that if I would indeed upload 100 labels 100 sentences per label, I would definitely have a much better precision. And I'm actually curious what the result would be then. And it also shows me a nice confusion matrix. And what can I learn from this confusion matrix? Well, I can see from all my labels that I created that actually, if there are any problems in my model, then the problems will be in the categories restaurants and shopping, because there's some overlap here. And then that made me think, it's like, yeah, because you can buy a pizza in a store, or you can eat a pizza in a restaurant. So that's probably why this difference is there. Now, let's try it out. Let's just test it. We go to the Predict tab. And this is really nice. Now I can just start testing out my model. I can start typing here. So if I say, like, how much have I spent on eating out? I'm not using the word restaurant. I'm just talking about eating out. Predict. And there you go. It's 100% sure I'm talking about a restaurant. This model works. Now I can start using the REST API in my application. I can build it in my application, and I can play around with that. Which is something that eventually what I want to do with my example is I want people that they can make a photograph of their receipts, and that it will automatically classify if it was a taxi or if it was a restaurant. That's interesting. So you saw actually by using machine learning, and we use machine learning to learn, and then on top of that we build more machine learning so you all can use machine learning. And I thought like, wow, that's crazy. This was AutoML and machine learning APIs. Now let's move over and look into the conversational AIs and see how you can start creating chatbots or Google Assistant apps. Typically, when people are talking about chatbots or AI for customer experience, yeah, people think like, oh, a chatbot that is just an iframe on a web page. But when I think about chatbots, yeah, I think about a lot more. I think about call bots or bots integrated in your IVR. Like, so if you call a call center, that they will start, that the bot maybe gives you an answer, or maybe that the bot is listening. And voice-activated speakers like the Google Home or the Alexa or Cortana, right? These are also all voice AIs. This is all about machine learning, because in the past, because the very first time, and when I heard about chatbots, I thought like, well, what's so special about chatbots? They already exist since the 80s or like the early 90s. It's like chatbots are there for a long, long time. But the thing here is, it's because of machine learning that the chatbots are now smarter. In the past, when developers would create chatbots, they did that through if-else branching. And that means like I had to very literally type in a message in the chatbot, and then if I would misspell it, or I would say it on a different way, the chatbot didn't know what to answer, and then I get a wrong answer back, and then nobody will use my chatbot anymore because, chatbot never gives the right thing back. And with machine learning, you can really understand what has been said and how can we give the right answer back to you based on what was being said. And we have tools for that. The Google Assistant is a kind of a chatbot. It's like the Google AI. The Google Assistant is integrated on Android devices, I believe Android 6 and up. And you can even run the Google Assistant on your phone, on your iPhone, through an app. And the Google Assistant lately also runs on all other devices, like on smartwatches, I believe even in the Google cars or in car systems. Like nowadays, a lot of devices, headphones, they all come out with Google Assistant integrated. So you have a personal assistant with you all day. That is what the Google Assistant is. The Google Assistant itself is the AI. The Google Home is actually just a device with a speaker and a microphone. The power is the Google Assistant, so the AI. So how would you create your own chatbot or Google Assistant app? Well, typically there are like 2 tools that you would need here. I mean, there are other ways how you can do it as well, but this is definitely the easiest approach. One tool is called Dialogflow, and Dialogflow, that is like a conversational UI tool. It's a web interface, so you go into the web interface and you start training your chat flows through this interface. And once you trained your chatbot, then you can choose how do I want to bring my chatbot live? Do I want to bring this live on a website or in an app? Or do I want to bring it live on a Google Assistant or Alexa? It's just like flipping a switch, and then it makes use of actions on Google. And actions on Google is kind of a layer in between the Google Assistant and your chatbot that has special SDKs, JavaScript SDKs, it's a Node.js SDK. And also has UX components. Maybe you're wondering, like, why do I need UX components? Now, maybe not on the Google Home, the speaker, but they're like, if you use the Google Assistant on your phone, or if you use the Google Hub or the smart displays, then suddenly you have a display on the Google Home. So then it's nice to show like buttons or to show like carousels, cards, that just enrich your conversation. Even though the conversation is over voice, it can just show things on display. So that is why what the Actions on Google does, it's actually like a framework that helps us developers to create cool stuff. Now, Dialogflow, maybe you have heard of this before. It was previously called API.ai. This company was acquired by Google. And Dialogflow, what it does the natural language understanding. So it understands what has been said, and it matches that to an intent. So it does intent matching. It means you type something, and then it matches, like with everything else, all the flows that have been created before, see which one has the highest confidence level, and that is the result that we return. And it works cross-platform. Let me first show you a Dialogflow before I move on. So this is Dialogflow. And when you log in typically with your Google account, then you can choose intents, entities, and fulfillment and integrations. Well, let's look into intents first. I created an intent here, transferring money. And I say, like, I'm gonna train this intent with training phrases. So there are all different types of ways on how I could train my model to make sure that I want to transfer money. I say I would like to transfer money to some destination. I like to send money. I want to send money. There are, like, typically if you would put 10 different training phrases in, then you will have a good model. And then it will start understanding it. Maybe you're wondering, like, what are these orange and yellow flags? Or why is some background colored? Well, those are parameters. So that means, like, if I have a conversation about transferring money, say, like, I want to transfer 100 euros, then 100 euro is a parameter that will be sent to some backend server, if I connect it to a backend server. Because Dialogflow is not transferring money. Google doesn't transfer money. No, it's you as a bank. Or if you order pizzas, if you create a pizza bot, you want to know which toppings. The toppings is a parameter that goes to your backend system. So you flag those as parameters. I did that. I said, like, this is an account, and if it's a required parameter, because I need to have a bank account number in order to send money. So if nobody tells me what the bank account number is, then I specifically gonna ask for it. I'm gonna ask, like, okay, to which bank account number do you want me to transfer this? And then you can start writing responses. Now, this is a simple example where the response comes directly out of Dialogflow. I can refer to earlier parameters that I used before. So I said, like, all right, this is the amount that you want me to transfer to some destination. But you can, if you want, you can hook it up to a backend. And then you just fill in a URL. You say, like, this is where my API server is. The results come from this backend server. And in an example of a banking application, that would mean, like, in the backend server, they transfer the money, and then it gives me a response back, like, yeah, that went fine, or okay, oh, that went wrong. And then it comes back to Dialogflow, and in Dialogflow, you want to make sure that it will be spoken out on a nice way. Now, I can integrate this with all kinds of things, like the Google Assistant. I just need to enable it here from this screen, and I immediately have a bot working on the Google Assistant. I can also deploy to web. I can deploy to Facebook. There's even a phone gateway that I can call to a number, and then I have the bot on the phone. That's really nice. Talking about call centers, if you like, because I'm really showing here, like, that you have a bot answering the phone. But maybe you don't want to have the bot answering the phone. Maybe you want just the bot to listen the whole conversation. Because I think one of the most common frustrations in call centers is that you always will put on hold. You always have to wait long. You get people on the phone that have no experience, or they give different answers back, or they refer you to a website while you're calling them to figure something out. Imagine that you have a bot listening to this conversation. Although you're speaking to an employee of an insurance company or whatever company, the bot can give the employee the answers on the screen and say, like, oh, this person calls for getting glasses. Maybe you should answer this to your customer. And that helps you, because that way you can have much faster response time, because nobody needs to put you on hold and look up, like, oh, let me look up the answer. No, the answer is there, and the answer is always the same. So there are lots of ways how you can integrate it too. I integrated with the Google Assistant and with a website. And let's test it out. What you see here is the simulator. I can test it. Hope it works. Maybe we need to refresh it. Let's see, look. So this is the simulator, basically. You don't necessarily need to have a Google Home device or an Android device. You can test it in your browser. You just talk to your test app that has just been linked up. I'm just wondering if the internet connection is there.
Sure, here's the test version of Babs the Banking Bot.
Hi there, I'm Babs the Banking Bot. How can I help you today?
And you can use your microphone here. So I use the microphone for my laptop. I would like to transfer money.
To which bank account number?
So Justus, what's your bank account number? 1, 2, 3. It doesn't matter what I'm saying here.
How much do you want to transfer?
€100.
To which country?
Where do you live? Germany? Netherlands? Netherlands? The Netherlands. The Netherlands. Let me try it again. The Netherlands. You see that it starts listening. And
All
if
right, I will transfer
thought something
100
else,
euros to bank
fixes
account.
it.
What's your bank account number, Netherlands?
Yay. Well, I mean, that was actually quite easy to do because I used Dialogflow to create the bot and I exported it to the Google Assistant. But I would have the same experience in my banking bot. So if I would go to the support, I don't know, somebody typed something in here that went wrong. Object. Well, let's try it. I say hi. Hello, I'm Babs, the banking bot, and I could say I would like to transfer money. All right, now this is nice. I've been showing this example around to my coworkers lately. I said like, oh, if you want a chatbot, I created something for you. Here you go, try it out. And my coworkers are all using it for their customers. And I was actually curious, like, what are people asking to my bot? Because then I can improve my chatbot over time. So I have another demo about that. Let me first switch to the slides. So if we look into this example, this is the banking bot, and the banking bot apparently works on a Google Home. I say I would like to transfer €100 to my wife, her bank account. What will happen under the hood is like it goes through the Google Assistant via the Actions on Google layer, then it moves it to Dialogflow. Dialogflow, that's where the intent matching happens, and the intent matching found a result. I need to connect to some API. This can be on-premise, on your own data center, or it can be an API on App Engine or whatever, and it returns me a result back. And now I'm curious which customers are unhappy and why were they unhappy, and how can I improve this experience, this user experience. I want to improve my chatbot and make it smarter. So here's what we're going to do. We're going to use lots of machine learning components that I showed you earlier today. First of all, we have the chatbot created with Dialogflow. We collect in real time all the chatbot messages. And we can do that. It comes with a Node.js SDK. We just integrate to that SDK. And immediately when a message comes in, we collect that message. Since this is a banking bot, a financial application, I don't want to store sensitive information on my or on my databases because of GDPR. So what I'm going to do is I'm going to use a machine learning model to remove sensitive information like phone numbers, like names or addresses, and I mask it for some fake data because I don't want to store that on my database. And then I'm going to understand the text. So that is the natural language understanding API that I showed you earlier. I will understand what has been said. I will understand if they're talking about a company or a person. And I will understand the sentiment, so if the user was angry or not. This is really nice. This is where I get the sentiment from. The next step is I will push it into a data warehouse. In my case, that's BigQuery. A data warehouse is like a database, but you can connect it to much more other sources. So you can run very fast or smart queries about this. So imagine that in my chatbot that I just showed you, I'm collecting every chatbot in the database with the sentiment, but I compare it to my Google Analytics data. So at that moment, I can see like, hey, this user was on my website, he was reading web pages about mortgages, and then he started talking with the chatbot, and the chatbot didn't answer what he was looking for. This person became angry. That is very interesting information for me as a company, right? So I know like what he was looking at, and I know what made him unsatisfied. And based on that information, I can go back to my Dialogflow and optimize my agent. So this is exactly what I've done. If I go back to my banking bot. So I created a dashboard that's connected to BigQuery database. And you can see here, over time, over this past week, I've been collecting almost 575 images, or 573 exactly messages I've been collecting from the chatbot. And from all those chatbot messages, about 80 were negative, where people got angry from, or people were upset. And we don't know why. Then I can see, because this is what the natural language API returned to me, it gives me a number back between -1 and +1. And in this case, it was like -0.8. So I can see like this is a very negative message from someone. I can sort in my database. I just query on the most negative messages, and I'm listing it here. So you see here, this person got really annoyed. And Dialogflow can give me the session ID. So since I'm storing every message, I can just query in my database for the session ID to figure out like what was the full transcript. And that is something that we could do. I hear this is, I think, the one that said like I'm really annoyed. And now I am querying for it. So under the hood, it uses BigQuery. And you can see here, like, this is what happened. The person came in, he asked, did my salary came in today? And the chatbot said, sorry, what was that? My salary, when will I receive it? Yeah, say that again. Did my company transfer me any money? Yeah, say that again. And then, I'm really annoyed. You see now the sentiment got really negative. So I learned two things here. First of all, my chatbot can't handle people that are angry because it keeps saying like, I don't know. And it doesn't know how to deal with people that ask for salary information. So I could go back to Dialogflow now, and I could at least create intents that help me. Well, at least the least thing that I can do is to make sure that people that are angry are getting a nicer answer back, like, hey, let me help you, or do you want me to live jump in the chat, and that then a real person jumps in and talks to you, for example, or I don't know, can leave feedback here. At least not, sorry, what was that? Yes. Right. For people that are interested, I did show the architecture on how this was created, this whole banking portal. It's an Angular application. And I have a backend application, which is the chat server. The chat server, it's a Node.js image that talks to Dialogflow. Everything that has been set in the front end goes to the backend through WebSockets. So then it's in the backend container, and the backend container can talk to these SDKs. And then every time when a message comes in, I push it to a messaging channel. And everything when there's a message in the messaging channel, a serverless cloud function will get updated, gets a trigger, and it starts running this flow, like going through the sensitivity filter to remove sensitive information, and then detect the sentiment from the natural language API, and then store it into BigQuery or in the data warehouse. And from there, I can push it back into the Angular app and in a dashboard. Yes. So, I hope you like my demos. If there is one thing that I want to give back to you today, that is that developers can use machine learning. You don't need to be a data scientist to play around with all this stuff. It's just a matter of using APIs, talking to these APIs. Yes, you can use TensorFlow for the JavaScript developers. There is a JavaScript version of TensorFlow. But we can also make use of the out-of-the-box ML APIs, or create your own model with AutoML. Take what Google made from the pre-trained models, train it with your own stuff. And the last thing is conversational. If you want to build apps for the Google Assistant, or for Alexa, or for the other chatbots, use the conversational tools that's there for you. With that, I'd like to thank you. I believe we have time for questions, don't we?
I think we still have some time for questions indeed.
Yeah.
So we can do a very, very quick Q&A, but I think 1 or 2 questions.
Yep.
And then we can go to the living room.
Yes.
So,
And I'm around all day, so people can feel free to come over and ask me stuff.
yeah.
Yeah.
So
There's a question.
I was just wondering, you were talking about sensitivity APIs,
Yeah.
filtering out sensitive information. Yeah, okay. Well, wow, this is really weird. You were talking about sensitivity API and how it filters out sensitive information in a way.
Yeah.
But you also said that you had to train the data set yourself. So
Yeah.
you basically had to tag it yourself with this is company information, this is banking account information. But when it comes to a company being held accountable for background information and
Yeah.
stuff like that, that actually seems to worry me. And I was wondering whether Google has built-in solutions for the big extreme example, if a crime is happening in the background and you actually record a crime, then you're held accountable for the recorded information.
Yes,
And
so
as
this API is exactly to prevent that.
Yeah.
This for software developers, they can make use of the API, and then you talk to the API. You can do it by every message that comes in, or you can do it, or you can just say like, here, this is my database. Now, please scan it, and it tells you all the sensitivity things that it has seen. Now, by default, it has things like passport number, phone number, address, blah blah blah. But you can create your own patterns, your own filters. And push that on top of it, so it starts recognizing it.
So it
Yeah.
has built-in solutions for crimes, for example, or
Then you need to create that yourself. That is something like if you want to do things like fraud detection, that's typically you create your own model. As a bank, you would create your own model for this. You could do that with TensorFlow, for example.
yeah. That's
Or
not
you can
exactly
use-
what
or
I
you
mean.
use
Is
both.
I mean information that you didn't mean to collect, which you can't predict because a crime happening in the background, for example,
Like what?
a murder.
Oh, yeah,
when
yeah.
you have Google Voice on and there's a murder happening in the background.
In the background.
You're, yes, a company, you are responsible for
Yeah.
disclosing that, and you actually keep a record of that the information. So you can't really account for the fact that you're recording that because it's data that you can't really predict.
It's tricky, yeah.
So there's no built-in solutions for
There's
that.
no built-in solution for murders in videos and has that role. If that is something that you're interested in, you can build that obviously because for example, their government is also making use of TensorFlow to create things specific for their industry.
Yeah. Okay.
Yeah.
Thanks.
You're welcome.
So I think that was it. Give a big round of applause for Lee, of course.
And Lee.
Thank you.
So we got a little token. Thank you very
Nice.
much
Thank
for
you
the
so
talk.
much. You're welcome.
It's a chocolate with Front Mini sticker on it. Thank you very much
Thank
for
you
the
so
wonderful
much.
talk.
Yes.